All right, guys. So here is number one on your 2.5 homework. So they give you this function, 7 times x over x squared minus 4. So they want to know what happens at 4. So let's look at the question. X squared minus 4. Shoot, I need to put the absolute values on everything. So right here. There we go. That's better. Perfect. Okay. So there's our same graph, it looks like. Yeah. So they want to know in the question, what's happening as we approach 2 from the negative side or the left side, and 2 from the positive side, the right side. So what is happening to 2?
It's an asymptote.
Yeah, pretty much. It's an asymptote. As we get really close, right, they can see that the function never really gets there. It actually skips and goes over it because it creates division by 0 at x equal 2 and x equal to -2. So we have 2 asymptotes there. Notice the red will never touch those green or blue lines. But if you look at the function itself, right? If 2 is that green line, -2, as I approach from the left side, make sure I look at the number. There's both 2, actually, they're both 2. So we're looking at this one. So as we approach from the left, the function shoots off to infinity. As we approach from the right, it shoots off to infinity as well. So both times it would be infinity. All right, so you can just type it in like that. That makes sense because it just keeps on going forever. I forgot they gave me a graph. Is there any questions about what they mean by an infinite limit?
It's because it's going up, right?
Yeah, exactly. Just because it shoots off as we get close to it.
Okay.
If it was shooting downward, it would be negative infinity. Like check out this guy right here. 1 plus x over 2. So x plus 2 has an asymptote at -2, right? So there's -2 right here. So -1, -2. So another asymptote. So as we approach from the left side, the negative side, you look at the graph, right? It shoots off downward to negative infinity. So that's where you put minus infinity. It's as simple as that. From the right, as I approach -2, it shoots upward. So it's going to be infinite. Any questions on this idea? So far, there's not much to do, just analyze a graph. There's nothing to solve by hand. Same deal here. So we have so it looks like an asymptote at -6, -2, 2, and 6. So as we approach -6, so there's -6. From the left side, it goes upward, and from the right side, it goes downward. So same thing. So 1, 2, 3, 4 are all the same deal. Except here, they stop giving you a graph on 4 and 5. So you get to graph it yourself and just look at what's happening at those values. Okay. Any questions on that?
For like, for example, if we had that question on a test, how would you want us to approach that for like doing it by hand instead of like putting it on an actual graph?
You can just sketch like a quick graph or explain in English and just say, well, as x approaches 2 from the left side or the negative side, the function goes to infinity, and you would just write infinity.
What I meant was that one that you were just looking at right now, when you go down and it wasn't on a graph, it just shows an equation. Like, how would you want us to approach that since we wouldn't, it's not actually on a graph and it just shows you the equation?
Well, you'd have to graph it yourself and then explain what's happening.
Okay, so like, will you allow us to like, the reason why I asked is because like, how do I explain this? Are you going to allow us to let us graph it, like let's say on our computer or something? That's
Well, that all depends on what's gonna happen. But
Okay.
if we stay online, I'll try to make sure you can open this window. There should be
Okay,
a
cool.
link inside the homework. You just click
Uh-huh.
in, this will pop up. Or
Okay.
you can use a TI-83 or 84, but you don't have to buy one. Or
Okay.
you can sketch this yourself based on the parent function of 1/x.
Okay, thank you.
But as far as returning to campus, it looks like you're pretty sure going back on Tuesday. So we'll see how that goes. Anyway. Okay. So you can still use the, let's see, -2. You can still kind of use this approach that we learned in the first section when you approach those numbers, the number, the limiting question, right? And you'll see that it starts to blow up. So it starts to give you an idea that, yeah, this is probably infinite, but the only way I would know for sure, I would probably put something really close to -2. If I'm not graphing it, I would plug in -2 point and then add like 20 zeros and 1 and just plug that in and see how huge this gets. If it gets really big, then you know this is approaching infinity from the left side. If it's really, really large but negative, then it's approaching negative infinity. But I prefer to just graph. I use a graphing utility or because this is kind of tedious. But it is a tool that you can use, and it's good to talk about it. Okay. Let's see if there's anything different that's more interesting where we can solve things. This guy looks. Find the asymptotes, if any, of the graph of the function. If an answer does not exist, enter does not exist. Okay. So here it wants us to find asymptotes. Do you remember in college algebra how to find them?
No, sir.
Okay, so I'm going to use x just because my t's look like plus signs. So x minus 3, x squared plus 9. Okay, so all you got to do to find vertical asymptotes is you take the denominator. Sorry, I got distracted for a second. And set it to 0 and check, are there real numbers that will solve this question? Can this be 0? Is the first question. If I solve for x, is there a solution? If I square something, will it become negative?
8. Oh, I'm sorry. I was looking at yours. X.
Not,
Oh, it'd be 3.
not if you
But-
use imaginary numbers, right?
Yeah, well, the only way would be, because if we use any real number, it would never be -9, right? It would only be positive. You can't square something and get a negative unless you use
Oh, yeah.
imaginary numbers. So there is no real number answer. In other words, there is no answer for a vertical asymptote. That's why it does not exist. No VA vertical asymptote. Okay, so that's all you have to do is look at the bottom and try to solve for it for rational expressions. That's what we did back in college algebra. Now, if you look at this question, you could also graph it and just look at it and see, all right, is there a point that they're approached, but I can't cross, right? Over here, we have one when we approach 0, because 0 is not defined in a logarithm. So x cannot be -3. So that creates an asymptote. So remembering the domain of ln or any log, that'll help you. Over here, it's just like I said before, set the bottom equal to 0 and solve. So that's something we've already done. Anyway, let's do 11. You guys have any questions on those so far before I move on?
For the logarithm one.
Mhm.
What's the domain and range for logarithms again?
Yeah, so for a logarithm, the inputs must be greater than 0. The whatever ends up, let me show you. Whatever is in here must be bigger than 0.
Okay,
And that cannot be negative, cannot be 0. Then if you graph it, it looks kind of like let me show you here. The standard ln x, right? Kind of looks like the diminishing returns from economics, right? Just kind of slow growth.
okay. Easy enough.
So yeah, the range is all real numbers, but the domain is never below 0.
Got it. So would
So
so the domain for logarithm would be pretty much positive infinity, right?
Yeah, it would depending what's inside. Like if there's a negative x in there, then it might reflect it, or a minus in front or something.
Oh, okay.
But the
if you
original,
had like
yes.
a positive 3,
What's that?
if you had a -3, would it have positive 3?
No, let's look at it. What is back in college algebra? We had transformations of functions, right? So if it was -3, this would be a horizontal shift. You guys remember that?
Mhm.
So +3 would be a shift to the left. Does that make sense?
Yes.
So the domains technically change because of the shift, but in essence, it's all based on the original. So
So
this
when they
one,
ask about the asymptote, is it asking what line it's sitting on?
so asymptote is right here. So let's get rid of these guys here. See how there's a value it can't cross?
Right, yeah, so that line would be the asymptote, correct?
Right, because we
Okay, gotcha.
cannot use -3.
Okay, just want to make sure.
So yeah, whatever causes 0 inside, that's your asymptote for any log type. Okay, so any questions on asymptotes? I mean, it's just a little bit of a review, but I don't mind talking about it.
Thank you for clarifying it, made it much better to understand.
That e to 2x, for that one, how would you solve it?
So here you have to remember, right? What causes asymptotes? So it's usually points that create like division by 0 or undefined points. About 90% of the time, it's division by 0. So all we have to look at is the bottom. The top doesn't really do anything.
So we just assume that -2 is 0 because on the bottom it's undefined.
Yeah, let's just go ahead and look at it. Let's see. So we had e to -2x, right, or something. Negative. Is that right? I think that was it. -2. There it is. So the e will never be 0. Right? So it's just a growth function. No matter what I choose for x, it will never be 0. But the bottom will create a 0. So it's going to be at 2. So that's where the asymptote appears. You see it?
Yeah. I guess the top really does not matter at all then. It's just the bottom.
Not really, no. I mean, the only time it might matter would be if there's like a logarithm on top or something.
Mhm.
Then you might, like, if, for example, if I had this function right here, I'm just
Mhm.
making up my own problem, right? If I divide this by x minus 2, then I'd have an asymptote there and an asymptote here. So I'd have two of them in one question.
wow.
So you could do that technically. So the top would matter in that case. So you just have to decide, all right, what's causing undefined values for my function? That's how you should think about it. But yeah, 90% of the time, the top doesn't matter, but not always. Okay, let's do 11. Let's shorthand this, find the vertical asymptote and see if the discontinuity is removable at x equals -2.
Could you factor it?
Yeah, so the factoring is what creates the or allows you to remove the discontinuity. So we factor the top using the difference of squares, right? You can cancel this piece. So this remove the discontinuity.
When they say remove, they want it by itself. Is that what they mean?
It means that it canceled out the problem
Okay,
that was creating division by 0.
gotcha. Okay.
So you remove it, so now you can now it's technically continuous. It's like a pseudo continuous.
So when the equation ends with saying x equals -2, pretty much it'd be kind of like an x plus 2, like the one that you factored out.
Are you wondering, say that one more time? Like, are you wondering where?
Yeah, sorry, that did not make any sense the way that I put it together, but basically I'm wondering how x equals -2 equated to the x plus 2, because I understand like discontinuity and removing it as far as like factoring out
Mhm.
everything, but I'm just kind of confused how x equals -2 is the same thing as x plus 2. Is that just because you solve for, or you put like 2 on the other side?
So so you see that this factored into these two, right?
Yes,
And then you see that these are common factors, so they cancel.
yes.
So the only thing left is x minus 2, this factor.
Okay, because
I mean, technically there's a 1 down there, but if you're wondering about this discontinuity was given because plugging in -2 is going to be a problem. So we have a shift back here. We're going to have a problem because of this.
Oh, okay. So then since you factor those out, it removes the continuity and you're able to use x or -2. Okay. Okay, that makes sense. Sorry. I had that completely arranged in my head.
No, it's okay. That's what we're here for, right? So let's graph it and see what it looks like. 4. Mhm. Okay. So notice how this is the same as, right? I already can't even see the other one to turn it off. -2, not +2. So they see how if I turn the green one off, you see the purple, right? It's in the same spot. So it's almost the same function, but if we look at the green one, the issue was at -2 originally, right? Down here. So it's technically still undefined there, but we're able to fill it in a way and remove the discontinuity with the factorization. And that's what we're doing. That's what they're talking about here. Like, is it removable? Yes, right? Because I was able to factor and cancel this problem. So that's all they're asking you to do. Like, can you do it? If you can't, and it stays a vertical asymptote, then you would just put vertical asymptote like this guy. There's no way this is going to cancel out because I can't do anything with ln. It's just going to stay there. So yeah, there's nothing I can do there. This guy I can factor. Well, this one only asks for one-sided limit, which we did in the last section. It's not very interesting, but if we do 13, just for the heck of it, it was x squared minus 3 or 9, 4. Okay. There we go. So x squared minus 4. So we have an issue at -2 and 2. So it wants to know what is the left. Determine one-sided limit of this function of 2 approaching from the left. So here's 2 approaching from the left. Is it 2 or -2? 2, sorry. There it is. Okay, 2 from the left goes to -infinity. There it is. So that's your answer. Now, is there any questions on these ideas? Do you see how infinite limits work graphically?
Yes, sir.
Okay. Oh, I see. I guess they wait till later for that. Okay, so we are off on Monday. And we pretty much finished chapter 2 for the most part. So that was a lot of time. Give me one moment. Okay, so assuming we're going back to school on, I won't see you till Wednesday. I'm thinking, what I'd like you to do, since you're going to be gone a while, is to go over the review and bring a bunch of questions on Wednesday, as well as homework questions. And then on Monday after that, will be we'll start, your exam 1 will be due, and we'll start chapter 3. Let's see here. Yeah. So I'll be opening all that up. So maybe we'll do maybe in class I can, on Monday. So I'm thinking if I leave your class, your exam open from the 9th all the way until the 12th. When I see you on Monday, the 13th, I'll just start on chapter 3. Okay. So let's make time for some homework problems, I guess, for now.
Yes, sir. Is it okay if I show you two of the problems that I had questions on in 2.4?
Yeah, let me go over there. 2-4.
Is there any way that I can share my oh yeah, there you go. Is it okay if I share my screen?
Yeah, go for it.
Let's see. 1 second. I don't know if it's this one. No, it's this one right here. Yeah, there we go. So I had is it showing?
Yes.
Okay. So I had a question with just 8 and 9, because I kind of understood the concept of it, but I wasn't sure how the website wanted me to enter my problem.
You would just enter the word none for x equals,
Oh. Wow.
because yeah, there is no issue there.
Let me see.
You can plug in whatever you want.
Oh, all right. Well, never mind.
On that one, actually,
Great.
I would say 2 and -2, because 2 squared is 4, right?
Yeah.
So-
So to how would I write that? It'd just be
Enter your valuation from the smallest to largest. So on the top one, put -2. X equals -2, and then no, the top,
on the top.
the first one, yeah. X equals -2 there, and -2 or +2 on the other one. Should be good.
Oh, okay. Awesome. Oh, well, I mean, those are the only questions that I really had. Let
Okay, cool.
me see. How do I? Oh, there we go. Stop.
I got you.
Professor, I have a question.
Mhm.
Really quick, I just want to go over our schedule with you. So you said our test is it on the 8th, or are we coming to class on the 6th, or is that
It looks like it. It looks like we're coming back to class on the 8th, because 6 is a holiday.
okay? Okay, I was just making sure. I was like, wait, I thought it was Labor Day.
Yeah, so on the 8th, that'll be the last day to ask questions about chapter 2. And then I'm gonna open the exam up
Mhm.
the next day and leave it open until the 12th. So you can take it anytime you want on Respondus. And then the 13th will start chapter 3.
Okay, and you said there's a review.
So I'd like you to
Yes.
start doing that review as soon as possible, or over this weekend, if not sooner. And then that way, when Wednesday comes, you'll have a ton of questions and issues and stuff.
Okay, and so if we do go back on the 8th, can you do you know where you're gonna be, like the room and stuff?
Oh yeah, it's on your schedule, but I can give it to you as well. Let me see.
It's just because I've been having a lot of problems with my computer, and so I don't even know if I'm gonna have my computer, because it like completely shut down this morning on my other class. So I
Mm.
had to like go on Zoom on my phone to finish my class, but like it was just acting really crazy. So I'm not really sure about my computer right now.
I getcha. It's going to be 119 would be our room. Science building 119.
Okay. And then last question, sorry. For the review, is that gonna be like a grade towards something, or
Let's see.
we just, we just do it for benefit for the test?
It is for your benefit for sure. I don't think I'm gonna include that as part of your grade though.
Oh, okay, okay. Because I need to play a little bit of catch up here. So I'm gonna try my best to get to it.
Yeah, I would try to get all your homework done like by Friday, and then just spend the weekend doing the test review. That should be
Uh-huh.
more than enough to be ready
Okay.
for Wednesday.
Okay, thank you.
Hey, sir, I have 2 questions about 2.3.
Sure.
Okay.
Wanna
Can
show
I
me?
share my screen?
Mhm.
Okay. right, so on number 3, I'm kind of confused on how to approach this. That's the first one. I was just looking at it and I was like, okay, I'm not really sure
Well, the first thing I'd say is try plugging in 9 and see what happens.
plugging a 9 to where X is.
Yeah,
So my thing is that when I did that, I got like a decimal number.
You have
Since
to-
it's a decimal, I'm not really sure how many digits it wants me to like put it to.
Well, you have to have
Hmm.
your computer in radian, or not your computer, your calculator
Okay, later.
in radians instead of degrees.
Yeah.
Oh, thank you. I didn't even think about that. Okay, hold on. Let's see, hold on.
yeah, try it out, see what you get.
Oh, thank you. Thank you so much. That was, okay, cool.
Oh, that's an
I
easy
fell
one.
down. Okay, and then the other one I had a question on, okay, so I actually had put in as ask your teacher. I literally looked at the same problem that we had went over, just different numbers, and I don't know how this is wrong on number 9.
So you did the conjugate?
Correct, yes. So basically, I rewrote the answer out, and as the conjugate, it was parentheses square root of x plus 2, on the outside is -9, and then parentheses x plus 2 plus 9. And on the bottom, it's parentheses x minus 79 parentheses square root of x plus 2 plus 9. So with the conjugates, it turned into parentheses square root of x plus 2 square minus parentheses 9 square. From the bottom, it's still x minus 79 parentheses and then square root of x plus 2 plus 9. So then the 9 square root, not square root, the 9 square becomes 81. So it's x plus 2 minus 81 on top. And then we add negative 81 to 2. That becomes x minus 79. I know the top and the bottom cancel out. So then all we're left with now is a square root of x plus 2 plus 9. So there would be a 1 on the top, and we just have that bottom remaining. And obviously we simplify it. So the x plus 2. So in the x, we put 79. So 79 plus 2 would be 81. So it'd be square root of 81 plus 9. So square root of 81 is 9. So that'd be 9 plus 9, which would be 10. So in final form, 1 over 10, but it says it's wrong, and I don't know what I'm doing wrong.
Yeah, I think you're, well, let's see, I'm almost finished with it. So your limit is approaching 79, correct? Is that right?
One more time.
The limit is approaching 79, correct?
Oh, yeah, it's positive 79, correct, yes.
Okay, so square root of 81 is 9, right?
Yes.
So that would be 1 over 9 plus 9, right?
Yeah,
So how'd you get 10?
you know what? I had a brain fart. Okay, I'm sorry. I don't know why I was thinking 10.
That's okay.
For some reason, I was thinking 9 plus 1, but
It sounded
I
like
don't
you had
know.
everything correct.
Yeah, I'm sorry. It's obviously 18. Hold on. Okay, look, I've just been
It
scrambling all over the
happens,
place
it
with everything.
happens.
So, okay, thank you. But that was all I had.
No, I like those kind of questions. Those are easy.
Okay, cool.
Anyone else have a question they want to do? Since we got some extra time today?
Can we look at 14 of 2.3?
Sure. Do you want to share yours or you want me to do a different one similar to it?
I could share mine.
Okay.
I have a sine 9t over 8t.
Sine of 90.
9
Like that?
over 8t. Yes, sir.
Okay, and it's the limit, right?
Yes, sir. As it approaches 0.
So remember, you have to get it in that form, right? So there's a couple of things you can do. I think the easy way would to get rid of that 8. It's just a distraction, right? So pull out the 8 in front because it's just a constant as t approaches 0. Now we have sine of 9t over t. Now I just need a 9. So multiply by the 9 over 9. So right here, right? So that will give us what we need. So 1/8 as the limit of t approaches 0. We'll have 9 sine of 9t over 9t. So once we take the limit, this guy goes to 1, right? So that'll be 1/8 times 9 times 1, which is 9/8. Because we need to have the argument match the denominator. That's all you have to do. So I brought in the 9 just for that reason. For your formula.
And to get rid of the 8, you multiplied it by 1/8.
No, I just factor it out because there's a 1/8 already there, right? Because it's on the bottom. So 1/8 times that would bring it back to an 8, right? On the bottom. You see what I mean?
Yes, sir.
Okay. Yeah, just factor it and ignore it till the very end because it's just in the way. It's not doing anything. Any other problems?
I know on number 13, I was just a little confused on that one on 2.3.
Which one? Sorry.
Number 13,
On the same section?
correct.
You want to share it?
Yeah,
Okay. I'll write down your problem.
just for 2.3 on 13.
13. So here we should do some, before we do anything, we got to change that cotan.
Right, yeah.
So this is 2, 3, right?
Yes.
2.3, 13. So the limit as x approaches pi over 2. So I'm just going to ignore the limit for now. 6 cosine x, cotangent x. So change that cotangent into cosine x over sine x. So that will be 6 cosine as x approaches pi over 2 times sine x over cosine, right? Because when you divide by a fraction, it's the same as, I should probably switch over. Sorry. Oh, actually, you're sharing. I'm going to stop the sharing.
Yeah, no, that's fine. Go ahead.
So we change the cotan into cosine over sine. That's just the definition of cotangent. Then you divide by this fraction. So that's the same as multiplying, right? This is over 1. You could show an extra step for no reason, but you don't have to. I'm just going to do it. So this will give me 6 cosine x sine x over cosine. So these will cancel. So now I have a limit as x approaches pi over 2 of 6 sine x, so that which would equal 6. Once you take the limit, you plug in pi over 2. Sine of pi over 2 is 1. 1 times 6 is 6.
Okay, I see. Okay, okay, I got you. Just letting that soak in for a second.
Oh, want to show an extra step, or is that okay?
Oh, no, yeah, that was good. For a second, I just had to look at it to make sure I understood why, like for a cos over sin, we reversed it. And I was like, okay, because we needed both of them to cancel out to the bridge, to just be 6 sin x equals, and then we found a limit.
Yeah, it's like if you had 6 over 2/3, right? You would have, that's the same as saying 6 times 3/2, right? You know what I mean?
Right.
So that's all we're doing. Nothing fancy. It's just that we have trig functions instead. Any other questions about 13, or is that okay?
No, that was good. I'm just trying to get that down. What? Can you pull it up a little bit? Sorry.
Here?
Yeah, you're good. All right, cool. And is the 2/3 from like converting pi over 2, or
I'm sorry?
is the 2/3 from like converting pi over 2, or?
No, this is just a random thing I made up. Just to
Oh,
show you,
okay.
just to remind you how fractions work, just in case.
Oh, okay, yeah, I was so confused. I was like, wait, what?
And I just pretend we had this problem, right?
Right, gotcha. Okay, okay.
The
cool.
same thing happens.
Yeah, for sure. Thank you.
Yeah, sorry, I didn't mean to confuse. Anyone else have, or anyone have any other issues? You guys okay then?
I'm okay, yes, sir.
All right, well, if you guys feel okay and head out, and if you want to stick around and do some more questions, feel free. So got about 30-ish minutes or so. You can also work
Okay,
on your
12.
drawing homework if you want. What's up?
12 of 2, 3.
12 on 2, 3. Okay. Do you want to show me your question, or?
Yeah, so mine is sine raised to 7.
Like that?
X. Well, not just without the.
Oh, it's on the, I see what you're saying. It's on the, right above the sign.
Yes, sir. Over X.
Okay. Well, let me give you a quick formula. One moment. Okay, so whenever you see that 7, basically what they're saying is this. It's like a weird shorthand. Just wanted to verify real quick. That's the same thing as saying this. Okay. Which means that if we had a 7 down here, we can combine it into one term with the same power. So if I introduce on top and bottom an x to the 7, So if I multiply the top and bottom by x6, then I would have what I need on the bottom, right? X6 times x would be x7, which would then allow me to bring all of it into one parentheses.
Out of curiosity, sir, where did you get 6 from? Or why do we have 6 there?
So the idea, my idea was that if I introduce x to the 6, this would make it a 7, right?
Okay.
Multiply top and bottom. Once it's a 7, then I can bring it inside and just say both are raised to the 7. You see what I mean? Like what the reasoning?
On the inside, yes, I just don't understand like the reasoning for like the left side. To,
The
like,
6?
yeah, you're right, yes.
Well, this is a 1, right?
Right.
So I need 6 more to hit 7. So I chose 6 of them.
Oh, okay, because we have that extra X that's just sitting there.
Right.
Okay, I see what you're saying.
So once they're combined, I can say, you know what, the limit, this inside limit would be equal to a 1 to the 7. This limit would be 0 to the 6. So I think it should be 0.
Oh, okay, I see what you're saying. It's kind of like the original formula with like 1, except that we're using different numbers. Or like the 6 and 7.
Yeah, it's the same as the last question you did. It was just it had a power of 7 in the way. So I was trying
Right,
to
okay.
figure out a way how to get rid of it.
Okay, for sure.
I think that's the easiest way I can think of. Can you try 0 if it works? See if it works. Well, I don't know if I wonder if it's gonna take it or not. It should though. Just show an extra step here. So you could technically,
It worked.
it worked? Oh, okay, cool. Because you can remember how there's a in that PDF I sent you with the limit rules, you could technically separate the limit and apply it to each one. Right? So this would be 0 times 1, 0.
So it wouldn't matter what numbers we had in there, it would just come out to be 0.
It's because of this guy.
So then, yeah, what I'm saying, like, even if it was 6, like, or 7 or 8, 9, it would still come to 0 though, right?
You mean this part, the 1?
Well,
Or as
the
the
one
actual
is
approachings?
one is gonna be the sine x over x1, and then whenever it's powered to, it's just gonna come out to be 1. So,
Yeah.
and then the other side is gonna come out to 0. So if you ever see sine x and it's like powered up like that, we can just always assume it's 0.
You have to, well, the word always is a big deal in math, so I don't like to
Mhm.
say it unless I prove it for every possible example that exists. I want to say Most of the time, if you see a big power, then yeah, because I need to introduce a variable like this. But there might be a
Mhm.
weird example that exists somewhere out there where it's not 0. But we should always show our work just to see what's going on, to be safe. But once you get to here, you should be able to see like, oh yeah, that's for sure 0 because of this guy.
Thought the 0 was coming from the limit.
Yeah, so the limit's telling you to approach 0, right? Plug it in. So I plug it in. So now this one goes to 1, so it doesn't matter because this one went to 0, so 0.
So if the limit was 2, you'd plug in a 2 versus the 0.
Yeah, you would plug in 2 if you can, if you're able to, and if not, you're gonna approach it and see what's going on.
Okay.
Any other problems? All right, so you guys okay then?
I think so.
For now, unless we have questions.
All right, if you guys want to
Yeah.
work on 2.5 and stick around, or if you want to head out, either way. But please do that review as soon as you can, as soon as you finish that homework. I think that'll help the most to prepare you.
How many questions are gonna be on the review?
I don't know. Let me click on it.
And for the review, are you gonna, I know you're not gonna count it as a grade. Well, I don't think you said you decided if you were, but if you don't, are you, like, would you apply it as extra credit or how are you gonna do that?
Right now, I think it's just for practice to prepare you. Let me see. There is 15 questions on the review. Doesn't look too bad. Looks similar to the stuff we've been talking about. I don't see. The last question, number 15 on the review, 14 and 15. I'm not going to test you on. So you can, whenever you can skip those. Don't worry about it.